We'll go for next. Next is the types of solids. We have two main types of solids. One is crystalline and another one is amorphous. Now, what are these crystalline and amorphous substances? We will see. Okay. Actually, you can make out from this diagram. This roughly I'll try to explain with the help of this. See, students, these are the constituent particles, and here you can say the constituent particles have a regular typical arrangement. That arrangement is ordered. You can see here all these molecules, they are in a one line, right? They are in one line. You can see vertically also, you can see diagonally also. So all the molecules, they have the regular arrangement. That arrangement is ordered. If the arrangement is ordered, then such kind of solids are called as the crystalline solids. And that thing is missing in case of amorphous substances. See, what happens in amorphous substances, the arrangement is not regular. You can't find out any regularity in this, right? Okay, maybe to some extent you will find, you can see some amount of regularity somewhere here, but not long range regularity. I can't even find even that also. Okay, so to some extent you can find, but not long. So the long range regularity is missing. So the arrangement of atom, ion or molecule is irregular, or they might show short range ordered, but it's not long range ordered. Right, student? So what's the first difference? The arrangement of particle is ordered in case of crystalline substances, whereas the arrangement is irregular. Arrangement is not ordered in case of amorphous substances, or you can say they have the long range order and amorphous substances have the short range order. Right? Another difference, because of this systematic arrangement of particles, they have the definite geometrical shape. I'm talking about three-dimensional shape, right? Otherwise, every solid they have shape that way. But if you see the geometrical shape, okay, so the crystalline substances have the definite geometrical shape, and which is missing in amorphous substances. Amorphous substances do not have three-dimensional geometrical shape because of this regular arrangement. Then crystalline substances have the sharp melting point, okay, but they melt over a range of temperature. Okay, now what do you mean by range of temperature? I'll try to explain. This is missing. Okay, yes. Now students, if you take example of benzoic acid, which is a crystalline substance, okay, so if you take benzoic acid 1 gram or 5 gram or 10 gram, maybe 1 kilogram or 10 kilogram, right? But and if you try to heat it, then the whole substance, means if you try to find out the melting point, then you can see the whole substance. Suppose you have taken 2 kilogram, the whole of 2 kilogram of substance will melt at one sharp point. At sharp one point, the whole substance collapse and it will melt. But things doesn't happen in case of amorphous substance. If you take amorphous substance and if you try to find its melting point, say that particular substance is having melting point around 80. Then around 75 degrees Celsius, the part of substance will start melting, and then 75, 76, 78, 80, 82, 85, till 86, 87, the whole substance melt. Means, what is the melting point? We can't tell any definite value. It has started melting at around 75 and the whole of substance melted at 88 degrees Celsius. So they melt over a range of temperature. They don't have definite melting point. Okay. Then if you see that cleavage in the sense, if you break it, okay, so after breaking, if you break the crystalline substances and the fragments which are obtained, it gets split up into the parts which you get, those parts or the fragments will have the plane surfaces, okay, means you get the regular cut. But if you break a amorphous substance, okay, it gets split up into the parts and those parts will have irregular surfaces, you get the rough surfaces. Okay, so on the cleavage is not clear here, and it can be cut into the regular parts. Okay, so on breaking we get the plane surfaces. Each fragment will have plane surface, and here on breaking the fragment will not have plane surface, but they will have irregular surfaces. Another difference is enthalpy of fusion. Now, what do you mean by enthalpy of fusion? What is fusion? It's a conversion of substance from solid into the liquid. It's fused, it's melted, right? So when you're heating it, because of heating, substance gets converted from solid into liquid. That is fusion. And how much amount of heat is required for this change? That heat is called as the heat of fusion or enthalpy of fusion. Okay, so crystalline substances have the definite enthalpy of fusion. Okay, for 1 gram or 1 mole of substance, the amount of heat required to change it from solid into liquid is definite. Fixed amount of heat will be required to change. but it is not fixed in case of amorphous substances. The amount of enthalpy, the amount of heat which is required to convert, which is required to fuse it, will be vary. It will vary. It will be different values. Okay, so they have the definite enthalpy of fusion. They do not have enthalpy of fusion. Another important property which you should know, students, is crystalline substances are anisotropic and amorphous substances are isotropic. So what do you mean by this isotropic and anisotropic? See what happens. Any property, you consider any property like refractive index or any property if you consider, and if you try to measure in any direction, so you know what happens in sometimes. So if that particular property is measured in a particular direction, you are getting some value, and if it is measured in some other direction, then it happens, students, that you are getting some other value. How it is possible, you will say. Okay, but it does happen, students, that in a particular direction it is giving one proper value, but in another direction it is giving another value. If it happens, then it is called as an anisotropic. If it doesn't happen, it is called as isotropic. So what are the isotropic substances? If the property is measured in any direction at any angle, then its value does not change. Such substances are called as what? Isotropic substances. Isotropy, that property. I repeat, if the property is measured along any direction, along any angle, then its value will not change. These substances are called as isotropic, and if the value changes, then they are called as anisotropic. Then you must be thinking, sir, in crystalline substances, the arrangement is pretty good in the sense that arranged pretty well in a well manner, right? Ordered manner. And if they're ordered, then why do we get the different values along different directions? That's the reason, students. Since their arrangement is regular, so suppose if I measure any property along this direction, I'm coming across this kind of particles. But if I measured like this way, then I'm coming across another kind of particles, and since another kind of particles, so definitely they will show some different property, right? Okay, if I go in this direction, I'm coming across only this kind of particle. If I go in this direction, again I'm going across, I'm getting another kind of particles. So here, as the direction is changing, the particle or that constitution is changing, and as constitution is changing, the property is changing. Right? So crystalline substances are what? They are anisotropic, and amorphous substances are isotropic. And last but not the least, very important point, examples. What are the examples of crystalline substances? Can I have any examples, students? Yes, crystalline. Sodium chloride. What you're thinking is correct. Sodium chloride, or any salt. Many salts are crystalline in nature. Copper sulfate crystals, they're crystalline. Sodium chloride is crystalline. And what are the example of amorphous substances? Sand is amorphous, glass is amorphous, okay, soil is amorphous, calcite is example of amorphous substances. So these are the examples of amorphous substances. So these are the differences. I repeat, the differences. In crystalline substances, the arrangement of particle is ordered. There is a long range order. In amorphous substances, the arrangement of particle is not ordered, it is irregular, and there is short range order. Crystalline substances have definite geometrical shape. Amorphous substances do not have definite geometrical shape, they are irregular. Crystalline substances have sharp melting point. Amorphous substances melt over a range of temperature. Crystalline substances, if they are cut, they give plane surfaces. Fragments give plane surfaces, and amorphous substances, they give irregular surfaces. Crystalline substances have the definite enthalpy of fusion. Amorphous substances don't have definite enthalpy of fusion. Crystalline substances are anisotropic, amorphous are isotropic, means if direction changes, the value of the property does not change, that is isotropic. Okay, students, so I hope you understood today's part. We will see further part in next lecture. Till that, bye.